Now that I know a little bit better how to actually use this thing, it turns out reading the manual is helpful. I know that the garbled screen of junk from last time, this is completely normal. The expansion interface is just trying to talk to a boot floppy disk, but there's nothing hooked up, so it's just screaming out into the darkness, hello, hello, is there anybody out there? And just waiting. What you have to do is you have to hold down brake while you turn on the computer, and ta-da, it works. And so now we're in level 2 basic, and I can actually check to see how much memory total is in this thing by doing print mem. And so as I predicted, while from the factory this had 0K installed, clearly 32K of memory has since been installed in this to give the system its maximum total of 48K of RAM. So, yay, great success. Now we can move on to digging into this thing and figuring out what some of this stuff is. Now, or some of these, the other additions that have been made to this, the two switches back here. Now, I've figured out what one of them is, because if I turn this off and turn this back on, okay, so with the switches in this position, there's a bunch of random characters, and this is just whatever junk happens to be in the display character memory at the time when the system's turned on. And you can see it's like some of the block graphics characters, numbers, and uppercase letters. However, if I turn this back off and if I flip this middle switch to the down position and turn it on, now, for example, I see a lowercase e here, a lowercase o, a lowercase h. So this must be an enable-disable switch for a lowercase character modification. And there were a bunch of those from various third parties for the Model 1. So that's kind of cool to have solved that. I've kind of played around with the other switch to see what it might do, and I'm not able to observe any differences in behavior externally. We're going to have to pry it open and look inside and try to figure out what the heck it is. So let's do that. Well, I think we've waited around long enough. It's time to open this thing up, see what's going on inside, and especially see if we can figure out what the heck these are and see what other sorts of random upgrades or modifications may exist inside this unit. So let's start by just opening it up. These screws, at least this one is pretty rusty. The other ones look okay. You can already see through the grates here that there's some kind of... I'm pretty sure that this is just the level 2 basic ROM upgrade, but we'll see. And it looks like the catalog number sticker that's on here is a little bit of a label on top of the label. So it says 26-01006-D. So I'm not 100% sure what that means, but I can look that up later. So That's interesting. I don't know that any two of these screws are the same size. All right, so it looks like, yes, there's a pair of short ones, a pair of medium-sized ones, and a pair of lengthier ones. All right, let's have the first look inside. Let's see, this is one. So that just lifts out. I'm gonna set. Holy smokes. So here's the first weird mod that I notice. And on this board it says copyright 1979 Bill Archbold. Oh no, there's no I. Archbold? Archbold? Not sure. And it has, what is going on with this? So it looks like these are just some 74 series logic chips. There's ground, plus 5 volts, out. This says, this little label down here says divide by 6. D0, clock. So I wonder, the keyboards on the original Model 1s were really crummy, and they were prone to bouncing. So when you would when you would press a key, it would register multiple key presses. I wonder if this is some kind of a debounce circuit, although this is also connected up to this, and this is a relay. What the heck is this? Okay. Let's see how to get this out the rest of the way. And these ribbon cables are super fragile and sketchy. Okay. So this edge connector up here is still really dirty. It'll be easier to clean now once it's fully out. Let's see. It seems like this is still attached. It doesn't want to let go. But, oh, is it these standoffs? Oh, wow. I think it's those standoffs, and it seems like they are, no, they're not fused. Okay. And that was, yeah, that's definitely what's holding it. And that one I'm just going to leave. Wow. What a oh, that's the other standoff falling. That made me nervous. What a crazy mess of wires going all over the place from these switches. So this switch connects to that Bill Archbold board on the other side, and also to this IC down here. And this switch goes to this IC, and something up here is weirdly connected through, and then an IC on top of an IC with lifted legs. And what in the heck is going on with this? And then this is connected into the ROM socket and goes around to that little ROM board on the other side. And that's the Z80 CPU. And that is a couple of big honking capacitors there. All right, let's carefully turn this back over. And what's interesting about this ROM board here. Wow, this is crazy. What's interesting about this ROM board is I don't see any copyright information on it. If this was the Radio Shack ROM upgrade, I would expect somewhere on that board for it to say, you know, copyright 19 something or other, Tandy Radio Shack Corporation, but there's nothing. And it does kind of have the look of an old school homebrew board. So what is what is this? What is any of this? So now I kind of have the conundrum of how do I figure out for sure that this is an actual lowercase character mod installed in this system. The difficulty is Level 2 Basic doesn't have a built-in way to print lowercase characters. Normally you could just do something like print character string 97 would be lowercase a, and you get an uppercase A because Basic doesn't know what to do with a lowercase character, so it just maps them all to uppercase. And I got to thinking about it. I thought, you know what? I'm a hardware programmer. I program hardware. It's what I do for a living. So I'm going to program this hardware. If Basic won't let me do it, I'll find my own way. So what I did is I looked up and found what the memory map is for the TRS-80 and figured out where video memory begins. Now, in character text mode graphics kinds of systems, generally this spot right here will be some fixed address in memory, and as you scan across each line, it's just the next byte in memory. And what gets written to each of these locations in memory is just the thing you want displayed in that character cell, and then the hardware uses that as a value to look up in a table in ROM that has the actual pixel pattern to emit out to the monitor. So it's a form of data compression, bandwidth savings, you know, whatever you want to call it. It's an optimization. So it makes things very easy in that if I want to display some specific character at that spot on the screen, I can just write that byte to location 15,360. Really easy. So there is a command in most implementations of Basic, including Level 2 Basic, to do that, and it's called the poke command. So what I did, here, let me clear the screen and list out my program, is I wrote a really simple program that clears the screen and then iterates from 33 to 255. 33 is basically the ASCII code where useful printing characters start. 32 is space. 33 is exclamation point, I think, and then goes all the way up to the maximal value that it can be stored in a single byte. ASCII ends at 126, I think, is the last regular printable character, but pretty much all of these kinds of systems that use text mode for their only display, there will be special characters beyond that. That's where like all the Petsky characters are, I believe. Actually, no, the Petsky is totally different. On PCs, it's where all the weird graphics characters are, you know, the bars and that kind of stuff. So from what I've seen of TRS-80 graphics, there's going to be some stuff up there. So as it's iterating across all the characters that I want to print, it starts at address 15,360 plus whatever the character is and subtracts 33 so that it'll start at 15,360 and just work its way across, and then stuffs that whatever character that is in there and just loops through and then hangs out at the end. If this weren't here when it got to the end of the program, it would print ready, and the prompt and the top 2 lines of the stuff that I had poked into video memory would scroll off the top, and I would be irritated. You know, hypothetically speaking, not that this happened to me. So when we're done looking at it, I just hit break and it's done. So let's go ahead and run this and see what happens. And sure enough, we get exclamation point, all the other punctuation, numbers, some more punctuation, uppercase characters, some arrows, an underscore, UK pound sign, ta-da, lowercase characters, some more punctuation, yen symbol, a hatch pattern, and then some various different kinds of block characters, and these are the kinds of characters that most TRS-80 games use to make their graphics. So you're in text mode, but and it looks like all of these are maybe basically 2x2 block patterns. I'm not sure. This is kind of a weird set of patterns, and it looks like maybe a lot of them are duplicated. But it can be treated as a very low resolution graphics display. Some fraction of the whatever the number of actual characters is. So yes, this definitely has a lowercase character mod in it. We can verify that. I wonder. So let's hit break. And then let's try flipping this switch. So it flickered. Let's see if it does something different now after flipping the switch. And look at that. Where before we had lowercase characters, we just have a repeat of the first part of the ASCII table. So definitely something different happens. If I weren't lazy, I'd power cycle this with the switch in this position and retype in that program and try it again and make sure that it was exactly the same display. But I'm not going to do that. I'm gonna guess that it would be the same. All right. Well, so yay, one mystery solved. There's still the mystery of that other switch though. And I don't really know what to do about that. After having done quite a bit more research on this mystery board up here, I've at least partially figured out what it is. There's still some weirdness about it. I'm not 100% sure what's going on, but I believe that this is what is called the Archbold Speedup Board, or sometimes just the Speedup Board, and there was a number of iterations of it. In the TRS-80, there is a 10 megahertz clock, and there is a circuit that divides it down by 6 to generate a 1.77 megahertz clock that gets fed to the CPU. Now, knowing that is part of what led me to believe that this was some kind of processor overclocking thing, because one of the lines that came out of that board was labeled divide 6. So that's seems like the processor clock line. After doing some research, I'm quite certain that it is some iteration of that board. So I needed some kind of way to verify what was going on. So I wanted to write a little program to basically run as a benchmark. Now, I haven't gone through and gotten any kind of I/O working on this yet. That'll be the next episode. So the only way that I have to get programs into this thing is the keyboard. So I had to come up with, what's a basic program that can run on one of these computers that I can type in and that will do some kind of computation that I can use as a benchmark. So what I decided to go with is a program that approximates the golden ratio using a Fibonacci sequence. So I've defined the variables that I'm going to use for doing the accumulation of the sequence as doubles. Now, if you're a modern C or C++ programmer and you think of IEEE double precision, this is not that. I don't know how these are stored. The basic manual says they take 11 bytes. I don't know. I know that the way that values are stored in this basic, it seems like 1 byte indicates what the type is, and then the rest is the actual storage. But I'm not. Anyway, doesn't really matter. They're not the double precision that you know. So it's gonna start the sequence at 1 and 1, iterate through. Now I picked 181 iterations because at 182 iterations, assigning B equals A plus C would overflow and the program would halt. So this is as far as it can go. But it's good enough because this lets it run for a while, and adding the extra print in here helps it run for a while. Originally I had it so it was just printing at the end, and it only took a couple of seconds to run, and so that wasn't enough work to be able to do an effective benchmark, because without disk basic there's no timer facility. The expansion interface does trigger. It has a heartbeat timer at a fixed interval, but the default level 2 basic doesn't hook up any of the mechanisms for that. The disk basic keeps track of the number of heartbeat counters, and then that combined with, I guess, you enter the date and time somehow, it keeps track of the date and time. So we would, with disk basic, we'd be able to do this as a proper benchmark of, show the time at the beginning, show the time at the end, do some math and figure it out. But instead, I'm gonna have to do it the cheesy way and use my stopwatch here. So we'll do a baseline run of this program to get sort of our base time. And it's pretty slow, and it's going to take a while. One of the cool things that sort of came out of necessity, I think, about the Speedup card is it's software enabled. It hooks into a particular I/O port and uses that as, should be about done here pretty soon, uses that as, so 26-ish seconds. Uses the value written to this I/O port to enable or disable it. Part of the reason that this had to be done is some versions of DOS, and I'm assuming the tape I/O routines in the default level 2 basic probably use busy loops or something for their timing. So if the CPU is running at a higher clock speed, their timing loops will be off and none of your I/O will work right, because it's using, how many times do I spin through this loop to figure out how much time has gone by to know how long to delay. You've got a heartbeat timer. You can just, anyway, but that requires knowing that you've got the expansion interface, so yada, yada, yada. So you can enable it or disable it at runtime, and it hooks into port 254. And that's why there was some of those wires that connected in that had address lines labeled on them and had data lines because it's looking for when those writes happen. So if we do out 2541, that's going to turn the accelerator on. Well, turn the accelerator on. Okay, so it just changes the clock source from the divide by 6 to, I think, a divide by 3. Most of the documentation that I found says that you go from the default 1.77 megahertz to 3.5 something. So we'll reset our timer and try this again, and this one will go by much faster. You can already see this is scrolling so much faster, and it's going to get done. It's going to get done pretty quick. The thing I don't know is what. So I missed it. It was done in probably 13-ish seconds, so it is roughly twice as fast. I don't know really what the switch does, and that's very confusing to me. I was thinking that maybe the switch is a hard disable or something. I'm not sure. I might have to look at it some more and try to trace some things around. The other thing that confuses me about it is that relay that's in here. The images, and I'll put some links in the video description. The images that I found about this clock replacement, clock generator replacement, whatever you want to call it, none of them had that relay in it. So I don't know what the heck that is. I've watched it, and it seems like what happens is when the computer first gets turned on, the relay will click really quickly, and then nothing else that I've observed doing, although I haven't tried writing to that port address while watching it. I can try that here in a moment. I haven't observed anything else. Certainly not toggling the switch back here doesn't seem to make that relay do anything. So we can actually do that experiment. Oh, stupid keyboard. Out 2540, so that turns it off. It seems like it doesn't really matter what you write out to port 254 as long as it's an odd number, because it's just looking at data line 0. That's the only wire that's connected to this other little board. So I'm going to, because of the way this cable's in, I have to turn it off and disconnect this cable to be able to take the lid off to look at this. All right. We'll take a quick pause while I do that. All right, so here we are, about as up close and personal as we're going to get. This little relay that is definitely connected to this. So when I turn this on, it will just momentarily click. Which I forgot I have the expansion interface. So you can just see it. It just barely flicks at all. And so let's see if writing to the port does anything to it. And it does not. How about writing the other way? 254.0. Nothing. So it just flicks for a second at system startup. I'm really not sure what that's all about. If you have any idea what the heck this thing is all about in here, I'm assuming it must help somehow with stability during startup, or I don't know. I am not sure. Please post in the comments below. That would be terrific. I'm going to go ahead and end things there. I don't think that I can do anything else with the weirdness that's inside that computer without somebody providing me with some additional information that I have not been able to find on the internet. The whole thing seems to work fine. I know how to control the clock modes, so I'm not really that worried about it. It is a pretty cool find, and I'm very, very glad to have that particular piece of computing history. In my next episode, I'm going to move on to trying to get some kind of storage connected up to this computer. I have several actual Radio Shack branded cassette tape players, and I have at least 2 of the special cables that you need to connect them. I also have the floppy disk drives that I had mentioned in my pickups video that I have the cables for and everything. I just need to hook all that stuff up and see if it works and figure out how to get it all going. I'm going to start with the cassette tape interface just because that should be the easiest, and it won't rely on any additional parts of the expansion, additional untested parts of the expansion interface working. The only challenging bit should be figuring out how to convert the downloaded cassette tape program files from the internet converted into audio so that I can record them onto cassettes and actually use them with real, honest-to-goodness cassette tape players. I don't think that should be that hard. So hopefully I will be able to get to that next week and keep making a few more videos about this during Septandy and having a good time with it. So until next time, try to remember the good stuff.